Hello, everyone. Welcome and thank you for attending today's IBM Community Webcast. My name is Anna, and I will be moderating today's webcast. Our topic for today is Into Data Science Lifecycle. All phone lines are currently in listen-only mode. Please note that audio is played through your computer or device. There is not a dial-in number. There will be a question and answer session towards the end of the presentation. You may ask a question at any time during the presentation by typing your question into the Q&A widget located on your screen, and we'll get to your question toward the end of the webinar. Tomorrow, we will have a recording of today's presentation available on IBM Community website. To access the presentation, please see the resources list in the top left corner. You will receive a follow-up email with a link to the archives as well. Now I'd like to introduce our speaker for today. We have joining us Jacques Roy, IBM Executive IT Specialist. Thank you, Jacques, for joining us today. The floor is now yours.
Well, thank you, Anna. Good morning, good afternoon, everybody. Good evening. Thank you for attending. It's really a pleasure to be able to share this information with everyone. So in this webcast, what I want to do is take a step back. In previous webcasts, I talked about machine learning, different machine learning algorithms. This time, I want to take a step back and talk about the data science lifecycle. And that data science lifecycle is based on the CRISP-DM methodology that stands for Cross-Industry Standard Process for Data Mining, and it's a modified version of it. And so I want to talk about this for multiple reasons, and the one main point here is that when we talk about data science, a lot of focus is on talking about data scientists and machine learning, but there's a lot more to it than trying to apply different machine learning and AI algorithms to solve problems, and that's what I want to cover here. So looking at this methodology, we can start with the first step, which is the business understanding, and you can see here, when we talk about business understanding, everybody that's been in the field, in business for an amount of time has some experience there. And it's amazing how we can get to some points where people will say, okay, we want to apply machine learning and AI to our company, but they can't define the business problem properly. And so, for example, they may say, I want to increase profitability. Well, that's not precise enough. So you want to be able to get more details. So is that I want to increase revenue per customer? And then that leads to other questions. And so that's the first step, trying to have a proper definition of the problem. And in fact, through the business understanding, you may end up having multiple more specific questions you want answered, which leads to multiple business problems that you want to solve. So the second step after that is take an analytic approach, and what that means is to be methodical in how you approach the problem. Now that you have a specific problem in mind that you want to solve, then you can ask questions like, what data do I need? What data do I have? What are the customer touch points? What are the current processes that are implemented right now? Do we collect all the information we need? And then decide over multiple possibilities. The next step after that is really through the data requirements that you've defined in the analytic approach, you can start looking at the data you have, you collect the data, and you go through it to find out what the data really is. For example, if you're in the insurance industry and you want to provide insurance for cars, you may want to get accident information. So that accident information can be part of the corporate data, but the thing is you may want to get access to outside sources. For example, multiple cities will keep track of accidents, of incidents like that, and they provide that data they make that data available. And so you think, okay, that data is available, I can use it. And so let me give you a simple example. In the city of Chicago, they have actually multiple files that relate to accidents, and one of them is that contains the speed limit at the time of the accident. So you would say, well, if you say speed limit of 70, 65, 60, 55, 50, 45, 30, 25, things like this, that's to be expected. But it turns out that in that official report available from the city of Chicago, you see all these different speed limits where you have 99 miles an hour and you have 0 miles per hour, you have 1, 2, 3, 4, 5, 6, 7, that are there. So when we talk about data understanding, that's part of it. You go through the data that you have, either your corporate data or additional data that you get from somewhere else, and you go through it to find out what are the characteristics of that data set. And so, for example, in here, when you look at the speed limit, you can say, well, does that mean that 0 and 99 means that the speed limit is not posted there? And what is this in terms of somebody that types that has a 26 miles an hour? Is that just a typo? They typed 6 instead of 5, and so that's why it's there. And so you can start looking at this and say, how will I react to this? There's two options. You can say, well, all the speed limits that are strange, like the 0 to 9 miles an hour and the 99 miles per hour and some of the others, I could simply eliminate them, and considering the number of records that are in the data set, that does not represent a large amount of records. On the other hand, you may say, okay, well, I can find other data sets that will tell me what's the speed limit on the different streets, different locations where the accidents were, and then correct that data. So that's what we mean by looking at the data requirement, collecting the data, and data understanding. That's just a simple example of what needs to be done. And I'll get back to that a little bit later because there's a lot more to it, and I want to focus on that aspect of data that I want to look at. And so the step after that is data preparation. So you look at your data, you may do some feature engineering. For example, if there's birth dates in there in terms of, for example, back to the accident, there's a birth date of the driver, for example, you may want to convert that to age at the time of the incident. And if you have longitude, latitude, you may, in terms of insurance companies, if it happens to be one of your customers, you may want to calculate the distance between either their home address or their work address to add other view of what that accident is about. And then there's missing data. Where do you find it? Weather information, more details on accidents, etc. And so in terms of the data preparation, there's also the idea that you need to convert some character values to numerical values, because when you talk about machine learning and AI, it deals with numerical values, and so you need to do that conversion. So data preparation, there's a lot of work to be done on that front. And when we look at all this, basically what we see is all that takes about 80% of the time in terms of data collection all the way to preparation. And so what that tells you here is that there's different types of people that need to be part of a data science team. And so to think that people that have a lot of expertise in data management are not useful to that type of team is really crazy, because basically these people know how to manipulate data, how to make it available in the proper format and make it available in locations and repositories that are optimized. And so that's just an example, and you saw even the previous steps. You need to have business analysts that are able to define and describe what needs to be done. So the idea of that data science is just about data scientists is really a very, very narrow view where when you spend 80% of your time basically on the data. And so once you're done with that, then you get to modeling. And so when you do modeling, you have different types of models that are created through either through supervised type algorithm, unsupervised, you do classification, do regression, etc. And so there's a lot of decisions to be made. There are a lot of different algorithms, lots of different approaches that can be taken. And even people that claim to be data scientists may not know about all the different algorithms that are available, may not know what's the best, and they will pick what they want. And so you get to a point where having some tools is important, because even after you decide on what algorithm you will use, you still need to worry about what's called overfitting, which means that your model fits the training data so well that it does very well with the training data, but doesn't necessarily do so well with other data that comes in. And so there's a lot of tuning to be done in terms of the overfitting and what's called hyperparameters as part of that. So once again, tooling would be very useful. Then you move from there and you say you evaluate, and so that's kind of part of what I just mentioned. You know, you have your training data, your testing data, your validation set, and so then part of your evaluation, you have to consider what would be the baseline. So to get into another example, if you do churn analysis, for example, and you say, well, the churn at my company is 5%. So what that means is if your model were to say no churn, no churn, no churn on all the records that come in, it would be right 95% of the time. So if you don't have a model that's more precise than 95%, you really didn't get anywhere with that. And so that's part of the evaluation process, to see what's your baseline so you can define if the model is useful or not, and that's part of the evaluation. Once you're done with the evaluation, you need to be able to deploy. And so when you get to deployment, again, that's part of the entire ecosystem of the tools that you want to use to be able to say, okay, I have my data, I know how to access it, I know, let's say I know how to catalog all that data, and so I know where to find it, and then after that go through all that understanding, which means that you need to manipulate the data and go through, do some basic statistics in different fields, do data preparation, and be able to do the modeling, evaluate your models. But you get to deployment, you need to be able to know how to deploy. You don't want to be left to your own device to say, okay, how do I deploy it to make it available to more people? And then after that, of course, you want to be able to collect some feedback on your deployments. And part of collecting that feedback includes looking at the results that you got. So that may be a bit of a manual process where you get some of that data and you evaluate if you were right or wrong. In terms of churn, for example, you can say, well, I got this answer that there was churn, and then you can check over time, over a short period of time, to say, okay, was the answer right or wrong? But if you took action already, then that defeats the purpose. And so there's a lot to be done in terms of trying to do that evaluation and feed it back to the modeling. The other part of that deployment and feedback is the idea of, once you have a model that is deployed, how often is it used? Is it used all the time, or is over time something happen and the application or applications that were using that model decided to move on to other things, and then that model is deployed using resources and basically is not useful anymore. And so you need that type of information to be able to do some cleanup. You don't want to accumulate deploy a bunch of models that eventually become obsolete either because they're not kept up to date or because of other reasons. Newer models were created with using different algorithms and deployed, and that model is not used anymore. So that's important to be able to complete that entire feedback loop here. And so once again, we have to remember that data collection and preparation, really that section of data requirements, data collection, understanding, and preparation takes 80% of the time. And if you don't pay attention, spend really a lot of effort on that aspect, what happens is when you get to creating a model, you can end up with a model that's basically garbage because it doesn't, it gives you the right answer based on what you have, but what you have as input is not very good. So what I'd like to do is talk a little bit about, in terms of that data preparation. I talked earlier about that speed limit where it was very surprising to find all these different speed limits when in reality there should be a lot more limited than that. And you need to make a decision on what needs to be done. But what about data bias? So when it comes to data bias, let's say, for example, you look at data that are seasonal. So in retail, you would say, well, let's say in November, there's a lot of activities that happen. And then you think about, well, there's that Black Friday. So that's a well-known fact. But no matter what, you have to look at the data you have and say, do I need to worry about a seasonal effect? And so that's why when companies talk about their financial performance, they may compare one quarter to another, but more often than not, they will compare, let's say, the first quarter one year with the first quarter of the previous year, for example, because that's that seasonal effect that makes for better comparison. So you have to be careful about seasonal, either if it's Christmas, Halloween, Easter, Thanksgiving, etc., so on and so forth. And so that's a well-known fact. I wanted to start with something relatively simple. And so the next one is I want to mention is the churn. So as I said earlier, if you have a 5% churn, you end up having a baseline of 95% accuracy if you say, well, it doesn't churn. But the thing is, how do you create a model with the data you have on churn to make sure that it's an appropriate model? If you use all your data, we've heard a lot about the person with the most data wins. But the point here is that if you have churn information, that churn information, let's say, represents 5% of your data. If you use your 100% of your data and create a model, most likely you'll end up with a model that would basically say there's no churn because it's overwhelmed by the data that says the churn is not there. So what that means is you need to process your data and be able to kind of provide a decent ratio of the non-churn and the churn data. So you will use, let's say, all your churn data as part of your data set and use either an equivalent number of records or can be more. I mean, there's some different ratios that you can use. But you don't want to overwhelm the churn data so you can create your model. So that's another aspect of the data preparation, data collection, data understanding that you want to be able to apply there. Let me move to another example, loan applications. It happens that I did work on a problem related to loan applications. And so what it turns out to be in terms of bias is that if you look at your data about loans to say, was I right to provide a loan to this requery or not, and you collect all that data, the thing is, before you decided to fund a loan, you had to go through multiple steps of approval. And so what that means is the loans that are funded could end up being in default or could end up being successful, but that doesn't really represent the proper picture of people asking for loans. And so when you create a model, you need to be conscious of the fact that since you've already applied some decisions on the data before you provided loans, you don't have the full picture. Maybe somebody else that didn't quite fit all your criteria would have been a good transaction. And so by looking at all that data, you know that there's bias that is already part of the data set, and you need to spend some time figuring out how you will handle it. Either one part of it could be simply that, well, that's what we have, and we know that the criteria we've applied are good. But if you have, for example, in your loan application, a criteria that says we will not loan money to anybody under 25 years old, that becomes the bias of your enterprise, and you need to still have a discussion to decide what to do. So finally, one more I want to mention in terms of, for example, hiring. And so that's actually a problem I've heard about from one of my colleagues, and I think it comes from actually a Google example on bias. And so what that is, for example, if you hire people only from a subset of universities, what happens there is that means that people that will apply that didn't go to one of those universities is at a disadvantage. And so you have to then look at your data and say, okay, now how can I unbias my data? And the idea there is to say that if that university has so much impact, is to try to reduce the impact, and that means you may have to go on the outside and find some statistics about the type of people you want to hire and what's the percentage of these people that go to that subset of universities that you picked, and unbias your data that way. Another thing would be similarly in terms of if you are if most of your hires at that point, if you have 80% of these hires that are male, so what that means is you have to look at the world in general and try to figure out what's the proper ratio that should be there to try to unbias your data. And you say, well, in terms of population and the type of people I want, let's say it's supposed to be 50-50, and I'm at 80%. So now you can unbias your data based on the gender of the person. And so there are some tools that help in terms of finding bias and being able to remove the bias of the data on the data. And so that's another aspect. And again, it's back to the beginning. What I said earlier is the fact that it's all about the data. You need to make sure that the data you have coming in is appropriate and is again, you're very conscious of the bias that's in there. You're very conscious of the type of data you have, and you manipulate it and you change it to better fit your business problem. And you have to find data from different locations, different places, and so you have to have a team of experts in different areas to be able to deal with all that that complexity of really understanding the data properly and then figuring out what's the best approach to model that data to get to your solving your business problem. I forgot to mention at the beginning, I have a YouTube channel called Bite-Size Data Science, and I have the link there where I talk a lot about data science, different aspects. In general, these are all roughly 5-minute videos, and so please go take a look, and you may find it useful, and please subscribe. In terms of tooling, one tool that I use, I work for IBM, so the tool I use is IBM Watson Studio. And so you can go look at the group I'm in, DTE, which stands for Digital Technical Engagement. We have a lot of information on Watson Studio at that link here. The DT demo site covers a lot of different products, and so this is the link you have there, ibm.com/demos. And what you have in there are short videos that describe what the product does and different aspects of functionality. There's what we call product tour that would simply require a few minutes, maybe 15 minutes, to go through it to get a feel for how the product works. And we have more in-depth tutorials that allow you to get your hands on the product. So I think that these are great assets to get familiar with a lot of different technologies. And finally, in terms of Watson Studio, I provide a link here that simply a short URL, so you can actually register to Watson Studio for free and be able to use the product and get familiar with what it does and do some experimentation in data science. Okay, so with this being said, I'm almost out of time, so what I will do now is start looking at the different questions here. So,
And we'll now open it up for questions. So if you do have a question, please type it in the Q&A widget located on your screen. And we've had some questions come in already too, Chuck.
Okay. So one question I have here is, how does the CRISP DM approach fit with agile development with sprints and scrums? Wow. That's really not a question I expected. It's how does it fit? I was part of a team that did agile development, and we did things and everything. So I don't have a good answer to that, but basically when you get to a certain point is you can divide the different sections saying, okay, well, you could have a sprint that says, we're trying to solve this specific problem. Let's find the internal data sources that are available, and that's part of the sprint, and get back to that. Another sprint could be then analyze different data sources to define what else we need. And so it's simply a matter of dividing the work in stages. And so when you look at this CRISP DM where it says, paraphrase here, actually I can go to I'll go to the appropriate slide here. It'll be easier. Go to the slide at the beginning. So you think about the data requirements, and so data requirements could be dividing it into looking at in different locations internally and different location externally, and then after that, when you do the understanding, there could be simply validation of these different data sources as part of your understanding, and say, okay, what are the characteristics? So to me, the agile development would come in the fact that the data understanding sends you back to collecting more data based on where you got to, and so that's part of the agile process of being able to take a step back, and it could actually, there should be more arrows in there in terms of going back, because it could go back to even all the way to redefining the problem based on what you have, where you can still get some benefits out of solving the problem, but because of the lack of data, you would redefine the problem and then park an idea of an extension to that problem later once you solve the subset of the problem based on the data you have, and that would create new requirements that would say, well, we need to start collecting more data of that sort for the future, so we can better address the original problem we have. And so that would be I guess my tie into agile development, and probably not exactly what you wanted to hear, but hopefully, Matthew, you still got something out of this. Okay, there are no more questions, so I will put in the answer in the Q&A in here, so no more questions. So in conclusion here, I just want to make sure that people understand that when it comes to data science, we need all sorts of people, and there are some people that have decades of experience in data management, data warehousing, business, running business, and all. So you need all these different types of people that work well as a team, communication being very important. And so you need to get all these people together to have a successful data science project. And once again, the key to everything in here is really the idea that when it starts, in a way, it starts and ends with data. You need to have the data, you need to understand it, and you need to make sure the data is appropriate, and be really aware of the characteristics of your data, the bias that may be inherent to your data, and what that data really means before you can say, well, I will create a model, because that model will reflect the characteristics of your data. So with all that, I'd like to thank you for attending my webcast, and hopefully I'll see you on my next one. Thank you very much.
Thank you, Jacques. So this concludes today's event. Thank you, everyone, for attending, and have a great day.